All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.3 in Algebra 2. This is our first video in the section. We're multiplying and dividing rational expressions. So let's start with numbers, because I know that a lot of people get frustrated in math when we introduce letters, so let's start with stuff we understand numerically. If I were multiplying three fractions, 15 sixteenths, 12 ninths, and 8 25ths, there are two ways to approach this problem. It is totally legitimate to just multiply straight across, because that's what multiplying fractions is, right? Multiplying fractions means that you're multiplying straight across essentially, and it means that it's this thing times this thing times this thing on the top and the same thing on the bottom. If I did that, and I kind of cheated and did it in advance and let a calculator help me, I would get 1440 over 3600, and that's fine, right? But if I don't have a calculator, it's not super fun to have to simplify this down. I can notice that they both have a 0 at the end, so I get 144 over 360. I can spot that both 144 and 360 are multiples of 12, so I can cancel a 12 and get 12/30ths, and then I can cancel a 6 and get 2/5. Great. But there's a better option. So it's a little bit inelegant the way that I typed it out, but I'll kind of walk you through it. So I typed this as, so what I'm going to do is I'm going to look at each one of these six numbers, the 15, the 12, the 8, the 16, the 9, and the 25, and I'm going to look at the factors of those numbers. Now, I could factor this farther. Instead of doing 16 as 4 times 4, I could do it as 2 times 2 times 2 times 2, but I don't really have to here, and I'll show you why. So if I look at these factors, right, so I factored the 15 into a 3 times 5 and the 16 into a 4 times 4, and you don't actually have to write out the factors, but it was the easiest way to write it when I was typing this for you in advance. Remember that I'm multiplying all these fractions, so all of these are actually secretly multiplication. Now, what that means is that if everything's being multiplied, I can cancel factors that occur in both the numerator and the denominator. So I can cancel this 3 with one of the 3's on the bottom. I can cancel this 5 with one of the 5's on the bottom. I can cancel this 3 with one of the 3's on the bottom that's still there. I can cancel a 4 with a 4 on the bottom, and I could cancel the 2, but I'm not going to, because there's a convenient 4 that can cancel with a 4, and what's left are the only two factors on the top and the bottom, which are a 2/5. So that's a much easier way to do this. Now, it might not look like it did here if I were doing this on my own, not in a way that had been written for you in advance. What it might look like instead, just to show you kind of the gist of what this might look like, is what I might do instead, and some of you have probably done this before, is I might say, oh, look, I can cancel a 5 from here and from here, right? So now instead of being a 15 and a 25, it's a 3 and a 5, right? I can cancel a 4 from here and here, right? I can cancel, at this point, I would say, oh, look, I can cancel both of those 3's with the 9, so the 9's altogether gone, right? And then I would say, oh, look, I can cancel this 4 with the 8 and get a 2, and sure enough, the only two numbers left standing are 2/5. So it might not look like you physically writing out all of the factors. You might just cancel numbers as you go. So let's go ahead and apply this to things that to expressions that have x's now, right? Because I think when we introduce variables, things get more complicated, but really, if you can keep your number sense and understand that these variables behave like numbers, it's not awful. All right, so example 1, we're going to simplify the 5x to the fourth over 15 times negative 3x cubed over 9x times a 12 over 10x squared. So again, there are two ways to do this. The better option is to cancel factors from the top and the bottom. So one option, right? So the better option, right? I'm gonna walk through the better option first, right? So option 1, and this is what I'm going to suggest you do, right? Do this. Is to either write this out as all the factors, which is fine, and then cancel factors that occur in common. So you could say, oh, it's a 5 and an x to the fourth, and a negative 3 and an x to the third, and then I could write the 12 as probably I'm going to write it as a 3 times a 4. I could write it as a 3 times a 2 times a 2, but I probably don't need to. And on the bottom, I'm going to write this as a 3 times a 5, right? I'm going to write the 9 as a 3 times a 3, and I'm going to write the 10 as a 2 times a 5, right? And if I do this, I can cancel a bunch of numbers, right? I can say, oh, look, there's a 5 on the top and there's a 5 on the bottom, right? There's a 3 on the top. Notice that there's still a negative there, and a 3 on the bottom. There's a 3 on the top and a 3 on the bottom, right? And I probably should have bothered to write the 4 as a 2 times 2, because I see now that there's a 2 on the bottom, so I'm going to rewrite this as a 2 times a 2 and say, oh, look, I can cancel one of the 2's, right? So what seems to happen if I do that, right, is what's left on the top is this negative and this 2, and then the x's. So I seem to get a negative 2x to the 7th, right? And on the bottom, I have a 5 and a 3 and the x's, and that's it, right? So I have a 15x to the third So I'm going to get negative 2x to the 4th over 15, right? And that's my simplified answer. Now there's other options. You could have just done what I did in the other example where you cross off things as you go, right? So if you felt more comfortable, you could have said, oh, look, the 5 and the 15 gives me a 3, right? The 3 and the 9 gives me a 3, right? The 12 and the 3 gives me a 4, right? And then I could use the 4 and the 10 and get a 2/5. And sure enough, what ends up left over is a 15 on the bottom, a negative 2 on the top, and then when I clean up the x's, I get that x to the 4th, right? Now there is that other option, right? So there is option 2, right? This is not great without a calculator, right? It's fine if you have a calculator, but it's not super fun without one. If I multiply all this stuff straight across, so let me erase so I can see what I'm doing, I could multiply the 5 times the negative 3 times the 12, right? So we could do 5 times the 3 times the 12 and recognize that it'll come out negative, right? So I could get a negative 180 on the top over with an x to the 7th, right? Because the x to the 3rd and the x to the 4th. And on the bottom, I could do a 15 times a 9 times a 10. And I'd get a 1350 over an x to the, there's a first and a second, so that'd be an x to the 3rd, right? And then I could use my calculator. If I have a calculator, I can simplify the 180 divided by the 1350. Oh, that's not a 50. And then hit math, frac, and it'll turn it into a 2/15 for me. Notice I didn't bother to type the negative in my calculator because I have a brain and I say, hey, I don't need the calculator to do the negative. I get that this is a negative 2/15, right? And then I look at this and say, oh, okay, that's a tug of war. X to the 4th wins on the top, and there's my answer. So that's fine, right? Multiplying straight across is fine, and it's a decent option if you have a calculator, but you're not always going to have a calculator. And I'm going to show you that when we stop using monomials, right? So these are all monomials. See how none of them have addition or subtraction? These are all monomials. So the calculator is not a bad option for monomials. It stops being a good option for binomials and trinomials, which we're going to see in a minute. So again, it's okay to try this, but I would suggest that you make sure you know how to do it without a calculator. All right, go ahead and try P1, and then we'll walk through it in a second. So pause me if you want to do it by yourself. Okay. Cool. So again, I'm going to suggest that there's a couple different ways to approach this. You can either do the thing where you just cancel as you go, right? Or you can list essentially what the factors are for this thing. So the 7 is just going to be a 7. There's not much I can do about that. X to the 4th. I'm going to rewrite the 9 as a 3 times 3. I'm going to rewrite the 12 as probably a 3 times 2 times 2 because I learned my lesson from the last time. 20, right, is a 4 times 5, but I could also write that as a 5 times a 2 times a 2. 21 is a 3 times a 7, and there's an x to the 5th there, right? And the 15 is a 3 times a 5, and then an x squared. So I'm just going to go through and cancel stuff I can cancel. Well, I spot the 7 right away, right? I look for a 3 to cancel, and there's a 3 to cancel. I look for another 3 to cancel, there's another 3 to cancel, right? I don't have another 3 to cancel, so I'm stuck with the negative, right? I keep the x's for now, right? I don't have another 3 to cancel on the bottom, but I can cancel both of the 2's, right? And so it seems to me that if I go through and circle the stuff that I'm left with, it looks like I end up with a negative 3 x to the 5th on the top, right? And on the bottom, I have a 5 and another 5 and then an x to the 7th. So 25 x to the 7th. So it looks like I get a negative 3 over a 25, and the bottom gets the x squared because x to the 7th is bigger than x to the 5th. Now, you can check that on a calculator, right? You can certainly multiply straight across. So if I do 7 times 9, again, notice I'm ignoring the negative because I notice that there's only one negative in the whole problem, so my answer is going to come out negative. So the 7 times the 9 times the 12, right? Oh, I didn't ignore the negative that time, but I meant to. Anyway. 20 times the 21 times the 15, right? And I can do that 756 divided by 6,300, and then I can math frac. Math frac, and there's your 325. All right, so in example 2, we're going to be multiplying rational expressions that are not monomials. So here's the deal. What this mathematically means is it does mean this binomial, the 8x cubed minus 8x, times this entire quadratic trinomial, x cubed plus 9x plus 20. Could you multiply them and FOIL everything out? Absolutely you could. However, if you did that, you'd get a huge x to the 5th polynomial, and on the bottom, if you did that, you'd get another huge x to the 5th polynomial. And then you'd have to use synthetic division to factor them to try and figure out what cancels, and it would be miserable. Instead, if what we do is fully factor each of these 4 polynomials and look for factors that cancel, we're going to have a much easier problem. So I'm going to go ahead and factor each one. If you want to do a little bit of the factoring work above the polynomial, that's fine. I notice there's a GCF here of an 8x, and what's left is an x squared minus 1, which is a difference of squares. So this first thing is going to factor into an 8x times an x plus 1 times an x minus 1. So that one's done. The second one, and I will add that it's easier to start with the ones that you find easier first. So for this second one, I'm looking for things that multiply to 20. My first thought is 4 and 5. It might be something else, but that's my first thought, right? They need to add to 9 and have the same sign. Well, that's pretty much definitely an x plus 4 and an x plus 5, and you should always FOIL to check. So again, the FOIL can happen internally in your head, but you should FOIL. So sure enough, 5 times 4 gives me the 20. I get a 5x and a 4x. Yep, there's my 9x, right? When we get down to the bottom one here, right, so I look here and I see there's a GCF of 2, and after I take that out, I have an x squared plus 6x plus 5, right? So the only way to get a 5 is a 1 times a 5 with the same sign, and that sign is positive for both. So I get an x plus 1, x plus 5, and this jives with what I'm expecting because I see both of those factors on the top, right? I'm looking for some factors to cancel, and don't forget that there's that GCF of 2 sitting out in front, right? When I factor the last one, right, when I factor the last one, there's a GCF of x, and then I have an x squared minus a 3x plus a 2. So I have this x, right? And then I'm pretty sure that this has to be a 1 and a 2 with the same sign, and that sign is negative. So I get an x minus 1 and an x minus 2. And again, you should FOIL to check, but I'm not hugely surprised by this because some of those factors, the x and the x minus 1, occur on the top, right? Now, it's very easy, so a common mistake here is to accidentally see this 5 and the 6 and use, like, let's say a 2 and a 3, which is not the right way to factor it, and you'll notice if you did that a lot of stuff doesn't cancel. So a good hint is that most of the time these problems are designed for a lot of stuff to cancel, and if something doesn't cancel, then you probably did something wrong. So let's walk through and see what cancels. We'll go ahead and use the yellow highlighter to see what cancels. So I see that there's an x plus 1 on the top and an x plus 1 on the bottom. That cancels. There's an x minus 1 on the top and an x minus 1 on the bottom. That cancels. There's an x plus 5 on the top and on the bottom. That cancels. And there's an x on the top and the bottom. That cancels. Lastly, I can cancel the 8 and the 2 to make a 4, right? So although the 8 and the 2 don't completely cancel, I can cancel them to make a 4. So it looks to me like what we have when all's said and done. So I'm going to cancel these, the 2, and make a 4, right? So it looks to me that the only stuff left is a 4 times an x plus 4 on the top, and on the bottom an x minus 2, and that's my answer. Now that's the factored form. The other way to write this would be to distribute the 4 and get a 4x plus 16 on the top, which would also be totally fine. Now you'll notice that your calculator is of zero help here because you can't just multiply the numbers, you'd have to FOIL everything out. So really there's no way to use a calculator. So when I go back to the earlier examples like this and I say that I don't just want you to get used to typing it in your calculator and leaning on your calculator to do the math, it's because when you have a problem like this, you just can't. Your calculator can help with some things, like if you're having trouble figuring out factors of a big number or something, but realistically your brain is doing most of the heavy lifting here. All right. Let's go ahead and do another example. So same idea, it's not wrong to multiply this quadratic trinomial times this one and FOIL everything out, but it doesn't get you to your desired end because then you'd have to use synthetic division to factor. So I am going to suggest again that you start with the easiest things to factor first, right? So I would suggest that you start bottom right. I would suggest that you start with the difference of squares, right? So I've got an x plus 1, x minus 1, right? And again, that kind of informs your decisions about what the other factors are going to be, right? So once you know some of the factors, it's easier to spot them. So I'm going to say that the next easiest one is probably this guy. A 4 is either a 1 and a 4 or a 2 and a 2. Since they're the same sign and that sign is negative, I'm pretty sure that's an x minus 1 and an x minus 4. When we go to factor the next one, right? I'm going to say, oh, look, an 8 is either a 2 and a 4, or it's a 1 and an 8. I want the same sign, and that sign's negative. Hey, look, that's pretty definitely an x minus 2 and an x minus 4, which, again, is not a huge surprise because, look, there's the x minus 4 on top. The x minus 1 has an x minus 1. Generally, a good number of these things are supposed to cancel. All right, and then when we do the last one, I see that the 2 has to be a 1 and a 2 with opposite signs, and I want it to come out negative. So I'm pretty sure we're looking at an x minus 2 and an x plus 1, right? So it seems to me, right, that what's going to happen in kind of a crazy twist of events, right? If we go ahead and use the yellow highlighter to cancel stuff, an x minus 2 is going to cancel with an x minus 2. An x plus 1 is going to cancel with an x plus 1. An x minus 4 is going to cancel with an x minus 4. An x minus 1 is going to cancel with an x minus 1. And then magically, we just get that the answer is 1. Right? So our final answer is literally just 1. Everything canceled. Right? Absolutely everything cancels. And that's not always going to happen, right? But that's the idea, is that sometimes everything's going to cancel.